looking at the idea of acceleration as a rate corresponding to set 2 problems, let's consider the case where velocity increases at 2 meters per second per second. Okay, this is a rate, 2 meters per second per second. How much change is there going to be in 8 seconds? Well, 2 meters per second means 2 meters per second each second. That's how much the velocity changes. If we had a speedometer, you can see the sketch of a speedometer down here with the needle moving, and let's say the needle moves by 2 miles per hour every second. It's going to move a second to here and another second to here and so forth. Now, instead of miles per hour, we could have a speedometer calibrated in meters per second. And we could have another vehicle accelerating at 2 meters per second every second, so that the speedometer would move by 2 meters per second every second. In any case, at 2 meters per second each second, then the change in 8 seconds is going to be 8 times 2 meters per second, or 16 meters per second. More formally, the calculation could be written 8 meters per second times 2 seconds, which is 16 meters per second times seconds, the meter per second times seconds. And the second here will cancel the second here, and we'll end up with 16 meters per second. Of course, the second in the denominator here might cancel this second, and we'd still have meters over seconds. It doesn't matter which second you think of canceling out if you think of the algebra here. Writing this in the form of an equation, we see that the change in the quantity, which is the velocity that's changing, the velocity is the quantity that's changing, so here we have change in quantity. Acceleration is the rate of change of velocity with respect to time. That is, in fact, our definition of acceleration, the time rate of change of velocity. So that's going to be the velocity change per unit of time, and we multiply that by the time duration, the number of time units, and we're going to get the change in the quantity, or the change in velocity. So the calculation then proceeds just as before. The acceleration is identified as the 2 meters per second, and I just noticed that we have an error here. Let me fix the error quickly. I had the right result here, but this should have been 8 seconds here, and this should have been 2 meters per second. Let me just use a little white out here to make that at least halfway legible. So if that was confusing you a minute ago, hopefully that alleviates your confusion. Okay? In any case, we're going to have to make the same change here. The acceleration is identified as the 2 meters per second. The time interval is the 8 seconds. So we get, in any case, the same calculation we had up here with the same units, or at least we get the same calculation we should have had up there in the first place. And we see that we have a change of 16 meters per second. Let's just note a couple of the smaller notes here. Okay, zooming in at what we mean by a meter per second. Okay, meters per second over second means meters per second per second. Meters per second measures velocity, so the meters per second over seconds measures the time rate of velocity change. Again, our definition of acceleration. And we can look at this picture of a speedometer here. We see that we have 8 2-meter per second changes. Okay, coming in a little closer. These are the depictions of the positions of the speedometer needle. And if we have a 2-meter per second change, then another, and another, and another, and then 4 more, then the total change has to be 16 meters per second. The flow diagram for the process just indicates that if we know acceleration, which is time rate of change of velocity, and the time change, then we can get the change in velocity.